Okay, we're going to now prove the triangle inequality that if x and y are real numbers, then the absolute value of x plus y is greater than or equal to the absolute value of x plus the absolute value of y. To do this, we're going to divide the proof into cases. So proof, okay, we divide into 4 cases. And the cases will be listed out here. Case 1. Case 1 will be that x is greater than or equal to 0 and y is greater than or equal to 0. If this happens, then x plus y is also greater than or equal to 0 by the axioms of arithmetic. And so the absolute value of x will be equal to x, since x is greater than or equal to 0. The absolute value of y is equal to y, since y is greater than or equal to 0. And the absolute value of x plus y will be equal to x plus y. Therefore, absolute value of x plus y is equal to x plus y, which is absolute value of x plus absolute value of y. And so this works, that we have an equality here as opposed to the greater than sign. Okay, case 2. X is less than 0, and y is greater than or equal to 0. Then the absolute value of x will be equal to negative x, where x itself is negative. And so the negative x would be positive, and absolute value of y would be equal to y. Okay, now here there are a couple of subcases because I don't know what about x plus y. So subcase 1 would be that x plus y is greater than or equal to 0, where this one is positive and this one's negative, but the sum turns out to be positive. Then the absolute value of x plus y would be just itself, and therefore the absolute value of x plus y would be equal to x plus y, which is going to be less than negative x plus y. Now this looks funny. The y's match. The x is negative, negative x is positive, and so therefore I have a less than sign here because this negative thing is less than this positive thing, which is equal to absolute value of x plus absolute value of y. And the practical upshot is that the left-hand side is less than the right-hand side. Subcase 2. Well, suppose that the sum of x plus y is negative, where that's a negative number and that's a positive number. But if I add them up, I get something negative. Then absolute value of x plus y would be equal to negative x minus y. Because x plus y is negative, so the negative of the whole thing would be the absolute value. And therefore, absolute value of x plus y would be equal to negative x minus y. Okay, now negative x is equal to absolute value of x. Okay, now here I have minus y. Well, so I'm subtracting off something that's positive. So this is going to be less than or equal to absolute value of x because this is positive, so if I take this minus a positive thing, that's less than or equal to the original thing. And that by itself is less than or equal to absolute value of x plus absolute value of y. So again, the net effect is that the left-hand side is less than or equal to the right-hand side. So either way, we have that the absolute value of x plus y is less than or equal to absolute value of x plus absolute value of y. Equality here might happen if y is equal to 0, otherwise it would be less than signs. All right, now case 3 is going to look very similar to case 2, but we'll write it out in full. Case 3. Case 3 is going to be that x is positive and y is negative. Then in case 3, absolute value of x would be equal to x, and absolute value of y is equal to y. And once again, we have two subcases involving the absolute value of x plus y. X plus y could be something that is positive or non-negative. Then the absolute value of x plus y would be equal to x plus y by itself. The absolute value of a positive number is the number. And therefore, absolute value of x plus y is equal to x plus y. And I should have had a minus sign here. I apologize. Y is negative, so absolute value of y is negative y. I apologize for that. Okay, now this is going to be less than x minus y. Again, this looks funny. Y is negative, so x plus a negative number is less than x minus the negative number. And that's equal to absolute value of x plus the absolute value of y. And finally, subcase 2, x plus y is less than 0. Then the absolute value of this negative sum would be equal to negative the number that's inside. And therefore, the absolute value of x plus y is equal to minus x minus y. Now, minus y is the same thing as the absolute value of y. However, minus x is something that is not positive, so this is going to be less than or equal to absolute value of y, which is less than or equal to absolute value of x plus absolute value of y. And so we have, again, that the left-hand side is less than or equal to the right-hand side. Okay, finally, case 4. Okay, case 1 was that they're both positive. Case 2 is that x is negative, y is non-negative. Case 3, x is non-negative, y is negative. So case 4, the only thing that's left is that x is negative and y is negative. Then, absolute value of x is equal to negative x, and absolute value of y is equal to negative y. Also, x plus y is negative. Automatically, if I take two negative numbers and add them up, I get something that's negative by the axioms of arithmetic. And so, absolute value of x plus y would be equal to negative x minus y, negative the inside. So, absolute value of x plus y is equal to negative x minus y. And negative x is absolute value of x, and negative y is absolute value of y. So in all cases, I probably should line this up with the C in cases. So in all cases, absolute value of x plus y is less than or equal to the absolute value of x plus the absolute value of y, and that's the end of the proof. I believe our textbook has a somewhat shorter proof of the triangle inequality. I like this method as a way of illustrating proof by cases, and a proof by cases actually might have subcases as appropriate.